Geometry Lesson 60, Proportionality Theorems. So, we're going to talk about proportions today. Theorem 60-1 is the triangle proportionality theorem. It says, if a line parallel to one side of a triangle intersects the other two sides, it divides those sides proportionally. So here's an example. It has triangle X, Y, Z. And by theorem 60-1, it says if you have a parallel line, which this little arrow right here says that AB is parallel to this side, YZ, then it's going to divide each side. So everything between X and A and everything between A and Y. These two are going to be proportional, meaning they're going to be equal, okay? I'm sorry, meaning you can write a proportion like a fraction. A proportion is a fraction. So this proportion, XA over AY, is proportionate or equal to XB over BZ. Basically, XA and XB are going to be the same, and AY and BZ are going to be the same. They're going to be equal to each other. So using that theorem, let's do our first example, which says find the length of segment AE. Right here, this length right here is what we're trying to find. I'm going to use my highlighters. We're looking for this length right here, from A to E. Now, it tells us from A to D is 2 units, whatever the units are, and then from D to B is 3 units. We're looking for the distance from A to E. It says from E to C is 5 units. Now, looking at this triangle, we can use theorem 60-1, which says if you cut the triangle with a line that's parallel, so this DE is parallel to BC, it says that, then these guys are going to be proportionate to each other. So you can write a proportion. So we can say that AE over EC, that's going to be our first fraction, equals, well, what is opposite of, or what's the same as AE? It's this 2 right here, which is AD over DB. It's just the sides right there. Now you can replace these letters or these segments with the numbers, okay? So AE is what we're searching for. It's going to stay the same. EC will replace with 5 because it says it's that long. So we have AE over 5 equals the length of AD. From A to D, it's 2 over the length of DB, which is 3. And then you just solve it. You cross multiply. That's how you're going to solve these guys right here. So AE times 3 and 5 times 2. That's cross multiplication. AE times 3, you're going to have 3AE. You always write your coefficient first. And then 5 times 2, which in this case is 10. So we have 3 times AE, or 3AE equals 10. To solve for this side, you divide both sides by 3. Cancel the 3's, so the length of AE is 10 over 3. And if you reduce that, you can reduce it more, but leaving it as an improper fraction is perfect. You don't need to go any further. For B, it says find the value of X. Okay, we have X here. So it's a triangle. It's cut by this line right here, and this line is parallel to segment NM. Now that means with our theorem 60-1, it means that this segment and this segment are going to be the same, 5 and 10, okay? Not the same, I'm sorry. They're going to be proportionate to each other. So we have X plus 1 over 5. That's going to be our first proportion. Make sure you work on the same side. When you're writing your proportion, you see how AE and EC right here, same side. And then AD and DB, same side. It's like a fraction, okay? So we have X plus 1 over 5. And then we have this side, X plus 3 over 10. To solve it, cross multiply. If it helps you, put parentheses around your polynomials and then cross multiply. So it's going to be like this, x plus 1 times 10. I'm going to put the 10 in front. You always put your coefficient in front. So 10 times x plus 1 equals 5 times x plus 3. Okay, now to solve this, first thing we need to do is get rid of these parentheses. So we're going to use distributive property, 10 times x and 10 times 1. So 10x plus 10 times 1 is 10. Right here, distributive property, 5 times x and 5 times 3. 5x plus 5 times 3 is 15. Add your like terms, which in this case, the x's are like terms and positive 10, positive 15 are like terms. To add the x's or combine the x's, I'm going to subtract 5x from both sides. Here it's positive 5x, I'm going to subtract it. That adds up to 0 on the right. On the left, 10x minus 5x is 5x. Bring down your 10, and then bring down the 15. I'm going to move over here. We have 5x plus 10 equals 15. We want to get x by itself and solve for x, so that's what they're telling us to do. So subtract 10 from both sides. We want the x all by itself. The 10's cancel. 5x equals 15 minus 10, which is 5. To solve for x, you do the opposite. This is 5 times x. You're going to do the opposite. You're going to divide by x. Or I'm sorry, divide by 5. Those cancel, so do these. So you get x equals 1. 5 divided by 5 is 1. So that's your answer. All right, there's another theorem, 60-2. It's the converse of the triangle proportionality theorem. It's pretty much the opposite of the one that we were just doing. It says if a line divides two sides of a triangle proportionally, so this line's dividing this triangle into two proportionate sides, just like I said up here, then it is parallel to the third side. So here's our triangle, XYZ. Right here, XA and AY, if you can write a proportion using this 60-1, we just wrote proportions, then it means that this line is parallel to segment YZ. Basically up here, it said if your lines are parallel, then you can write a proportion. Down here it says if you can write a proportion, then line AB and segment YZ are parallel. So it's just kind of going the opposite way. All right. Example 2. It says, is segment ST parallel to segment PR? So ST to PR. Are these guys parallel? Can we put the little arrow sign on them? Okay. So let's see. I got an eraser, you guys. Okay. Using theorem 60-2, it says that if I can write a proportion for this triangle, then line ST is going to be parallel to segment PR. Okay, so let's see if we can write a proportion using theorem 60-1. So remember, use the same sides. So PS, or this length, over SQ. It equals this side, RT over TQ. Now all you need to do, we know the numbers. They gave us 3, 8, and 2, 7. Plug them in. So PS is 3 over SQ, which is 8. RT is 2, and TQ is 7. Okay? Cross multiply. I mean, you can look at it now. It's not the same. 3 8s and 2 7s aren't the same. But if you cross multiply, you'll be able to get an actual number. Okay? 3 times 7, which is 21, and then 8 times 2, which is 16. 21 does not equal 16, okay? Put a little line through it. It does not equal 16, so line ST is not parallel to segment PR. Okay, so you can write it out, or I guess you could use your symbols, huh? Okay, so this is our answer. Segment ST is not parallel to segment PR. Okay, theorem 60-3. It says if parallel lines intersect transversals, then they divide the transversals proportionally. So you should know what a transversal is. It's this line right here and this line. It's cutting parallel lines. It's cutting through parallel lines. So it says if parallel lines, these guys right here, A, B, C, D, and E, F, they're parallel because they're denoted with the little arrow here. If they intersect transversals, so if they cross through a transversal, they do here and here, then they're dividing the transversals proportionally. So you can write a proportion for these transversals. From A to C over C to E. Again, work on this left side or the right side, or the top and the bottom, okay? And then B to D over D to F. So AC over CE equals BD over DF. That's these guys right here. Let's actually do a question. Or I'm sorry, we have one more theorem. Theorem 60-4. If parallel lines cut congruent segments on one transversal, then they cut congruent segments on all transversals. So here in this diagram, we have transversals right here and right here. These are the transversals. These are the parallel lines. You can tell just by looking, but don't just assume, okay? This tells us with the arrow that they're parallel lines. Okay, so they are cut by, if parallel lines cut congruent segments on one transversal, then they cut congruent segments on another transversal. Congruent just means they're equal. So these parallel lines cut through this transversal, and from X to Y and Y to Z. So segment XY and segment YZ are congruent if segment UV and segment VW are congruent to each other. So if UV equals the same as VW, then XY equals the same thing as YZ. UV and XY might not be the same, but XY and YZ are going to be the same. Okay. Example 3 says use a paragraph proof to prove theorem 60-4. Okay. Here we have 1, 2, 3 parallel lines. You know that because of the little arrow. We have transversals right here. Transversal AC and transversal DF. It does tell us that these two are congruent. Okay. So I'm going to write down what was given. Okay. But it does say that segment AB and segment BC are congruent. That's what this symbol means. So what they gave us was that segment AB is congruent to segment BC. AB, BC, and we know that right here. We also know about the parallel lines, okay? We know that line AD is parallel to line BE. AD and BE, they're parallel. And we know that line BE is parallel to line CF. And if AD is parallel to BE and CF is parallel to BE, that means that AD and CF are also parallel. Okay, so these lines are parallel to each other. We need to prove that segment, this guy right here, DE and EF are congruent. Okay? So let's see how we can prove that using theorem 60-3 and 60-4. Okay? In theorem 60-3, we know that if we can write a proportion, so AB over BC, then DE over EF equals that. Okay? So here's our proof. AB over BC is equal, I'm sorry, I wrote congruent, is equal to this segment, DE over EF. And we know that because of theorem, write why you know it, theorem 60-3. Okay? Since these two guys are congruent, then you can use substitution if you want. But because these two guys are congruent, then DE and EF are congruent. Okay, segment DE is congruent to segment EF. Because of theorem 60-3 that tells us if you can write a proportion, then that means that they are going to be congruent to each other. Okay? Next example. Finding segment lengths. Okay? They're going to give us now, instead of just numbers, we're going to have polynomials or variables in it. It says find the length of segment AB. So we need to find the length of this segment. It gives us a polynomial that the length of this segment is x plus 3, but we got to find out what x is so we can actually find the number length. Okay? So we can write, because these three guys are parallel from 60-4, we have three parallel lines that are cut by a transversal. Then you can have these two x, y, and y, z are going to be congruent to each other. And UV and VW are going to be congruent to each other. So because we have three parallel lines cut by two transversals, we can write congruent equations. So it means that this length of AB is equal to the length of BC, or x plus 3 equals 3x plus 1, or minus 1, I'm sorry. So these two segments are congruent because look, DE and EF are both the same. They're congruent to each other. So then AB and BC are going to be congruent to each other. Solve for x. I'm going to move 3x to the left side. So x, or 1x minus 3x, is going to be negative 2x. And then subtract 3 from both sides. Negative 2x equals negative 4. And divide by negative 2 to solve for x. Cancels, x equals positive 2. The length of AB is not positive 2. That's what x equals. We can plug that in here to find the length of AB. It equals x plus 2. I'm sorry, x plus 3. And plug 2 in for x. So the length of AB is 5. That means this is going to be 5. Check it just to make sure, okay? BC equals 3x minus 1. If you plug 2 in for x, you get 6 minus 1, which is 5. So yes, they both work out when you plug 2 in for x. So for a question like this, you need to first solve for x, but don't stop there. You need to plug it back into, in this case, it was a polynomial. So plug it back into that function and see what the length of this segment is. Since this one's 5, segment BC should also be 5. So we found our answer. Segment AB, or the length of it, is 5. Next, determine whether line UV, this line, WX, and YX are parallel when x equals 3. Okay, so we have 3 lines right here. They look parallel, but you can't assume it. It looks similar to up here. We have the two transversals right here, UY and VZ. This transversal and this one right here. We're going to use the theorem that says if you have two transversals cutting these 3 lines into congruent segments, so if UV is equal to WY, then these 3 lines will be parallel to each other. So let's see if these guys are congruent to each other. 14, Vx is 14 and xz is 14. These two are congruent, so these are going to be congruent. We can write an equation, 4x minus 1 equals 5x minus 3. Solve for x, subtract 5x from both sides. 4 minus 5 is negative 1, or negative x. Add 1 to both sides. Negative x equals negative 3 plus 1 is negative 2. Divide both sides by negative 1. You have x equals positive 2. We've solved for x. We need to... Oh, did I do that wrong? Minus 1. They gave us the X right here, guys. I was just going along by myself. Let's try it with the 2, see if they're congruent, and then we'll try it with the 3 and see if they're congruent. Okay, so this is segment UW, 4x minus 1. If you plug 2 in, 4 times 2 is 8. 8 minus 1 is 7. So this guy right here is 7. Let's find out what WY is. 5x minus 3. If you plug 2 in for x, you get 5 times 2, which is 10, and 10 minus 3 is 7. They're both congruent to each other when x is 2. What about when x is 3? Let's do it here when x equals 3. Plug 3 in for x for segment UW, and then plug 3 in for x for segment WY. All right, 4 times 3 is 12. 12 minus 1 is 11. So when x is 3, segment UW is 11. Let's see what WY is. 5 times 3 is 15. 15 minus 3. What's 15 minus 3? It's 12. Okay, so when x is 2, it works, but when x is 3, it does not. Okay, so these guys right here, this line, and this line, the 3 lines are not parallel. So you can write it as line UW, line WX, and line YX are not parallel. You can, instead of writing are not parallel, you can put parallel lines and then put a line through it. That's what it means. Okay? All right, and that is your last example. Your homework is lesson 60, questions A through E, and I will have that on Plus Portals. I'll talk to you guys later.